Hello everyone, welcome to Coding Bits. Today we'll solve the problem called Count Binary Substrings. It's a leetcode problem. Let's first look at the problem. So, given a string yes, we should count the number of non-empty contiguous substrings that have same number of zeros and ones, and all zeros and ones in the substrings are grouped consecutively. Substrings that occur multiple times are counted the number of times they occur. Let's also look at the example. So we are given a string which is 00110011. So as per the question, we are asked to find the number of substrings in which there are equal number of consecutive zeros and ones. That means if we are taking a substring 0011, here there are two zeros and two ones, which are equal number and also both are consecutive, like zero are consecutive and one are also consecutive. And another substring which can be formed is 01, where number of zeros and ones is one, and they are consecutive also. And the 1100 is also the one of the substring where we have two ones and two zeros, the consecutive, and 0011 and also 01. So in this way, there are total six outputs possible for this input. Let us look at another example. The string is 10101, and the substrings what we want is 10, 01, 10, and 01. So there are four substrings which are having equal number of zeros and ones. So so first let us try to think of a solution here. In a normal brute force approach, what will be the first idea is, let us say this is our input 0, 1, 0, 1, 0, 1, 0, 1. So this is our input. So normal brute force method, we can check for each substring and we can count. Uh, yeah. So in normal brute force method, we can check for each substring by iterating two variables I and j, and we can iterate over that substring and find whether the consecutives of zeros are equal to consecutives of one or not. In that way we can do, but this is a very lengthy approach. Like it takes big of n cube time to find the number of substrings in the string. But so if we try to optimize it in a different way, what we can do is instead of checking uh, for every for every string whether there are consecutive zeros and ones and whether they are same number or not. Instead of doing that all the time, what we can do is uh, we can maintain a hash map where we can store uh, the number of zeros and ones present in this window. Let us take a window. So as you know, this window should be of even size because uh, as per the question we have to find the same number of zeros and ones which substring contains same number of zeros and ones. So let us say if there are x zeros and there should be also x ones in that substring. So this is an even. So that means the our window should be of even size, and we cannot form a substring because we don't have to check for a substring of odd length because in that there is no occurrence of same number of zeros and ones. So we should always check for even sized windows. There is one catch point here. So let us take for initial size 2. Suppose our Windows initial size is 2. This will be our first window. So in this first window, we will have, so while iterating in the substring, in the string, so we should make a count. Let us say this is our window. So the count of zeros and ones is 1. Both 0 and 1 is 1. So in this window, our map contains the map of keys zeros and one has value 1 1. So this means that the zeros and ones are same, and we can check whether they're consecutive or not. How we can check for the consecutiveness is if let us take from I plus 1, let us say this I. So from I plus 1, what we should do is we should check for the previous value if they are same or not. And here they are different. 0 is not equal to 1. So that means there is one different point here. Like what we can say is like a breaking or a distinguishing point where uh, there is uh, uh, indifference. So that indifference should be one in the window where zeros and ones are same. So as all the cases are met, so we can say that this is our one of the substring. And in similar way, now what we can do is, let me erase this for better visibility. Mm, yeah. So now what we can do, we should our window size is same, two only. Now we will iterate for the next point. When we iterate for the next point, we will dequeue this one and enqueue one here. If, let us say our window is a queue, so we will append one to the rear end and delete one from the front end. So now 0, 1. Again, the number of zeros and ones are same. Now we can check for whether they are consecutive or not. So you know that how to do that. So now again, like we'll have only zeros and ones and their consecutive. So it is also a required substring. So in that way now we will iterate till here, and after that we will increase our size by 2. So when we increase our size by 2, we will so the total window size is 4. Now here, let me erase the previous. Now I think this is somewhat clear. So now, so okay, this is 10101. So don't get confused here. So when we take size of 4, now here we can see number of zeros are 2 and ones are also 2. Uh, that will form initially. But if for checking for consecutiveness, when we iterate over this entire substring, what we'll find is that they are not consecutive. I mean, the ones and zeros are not grouped as per their individuality. They are randomly grouped here. So this is not our substring. And when we iterate over here, this is also not our substring. And if we increase the size by 2 again, it will be 6, but our substring is of only size 5. So we cannot iterate for the next size. So this is one of the method so we can do. But this is also not proper optimized solution. The time complexity here is again because when we iterate over we will iterate over the queue by forming sizes. So this is not also an optimized solution. So if we think of an idea, let me say one thing. If we get a question regarding equal number of check whether there are equal number of ones and zeros or not, which are consecutive. So the first idea what we will get basically how to check whether there is equal number of ones and zeros and they are consecutive in a substring. So that the basic idea we'll get is to use a stack. I think you might be all clear with this idea. Why we do stack here now? So stack basically what we can do, we can append ones over here if the ones are there, and as soon as we get a different value or zero here, we will pop all the elements from stack. So now as our stack is empty, and also if the string reaches an endpoint, it means that this is a substring which is having equal number of ones and zeros and they're consecutive as well. So this in this way we can find the substring. But the stack idea is also not a complete solution for this approach because we have to find uh, the substring inside a substring and we have to make a count of how many are present. Like suppose this is a substring present here, and let me say after this, let me again rewrite this. So if 111 000 is present, and this is not a complete string. Let us say there are more ones here. So what will happen now? Now the number of possibility of our answer is increased, right? So here we can see that here total three substrings can be formed, which are equal length and consecutive. And also now again these three also can be formed. Now you got my point why uh, only a stack is not important here. Like we should use a queue basically here um, to remove the elements from the first and to add elements as the last. So by using queue we can solve this because in this way we can still try to uh, like figure out next possible substrings from the string. So now so first let us see how can we do this problem. Like so basically when I take a queue here, I will append the first element into my queue. So that is my first element. Now let us say this is our queue. So after adding one, we will check whether the I, let's take this I, this ith value at the top of the rear of the queue is same or not. If they are same, that means we can insert into our queue and we'll move forward. Again, they are same, so we will insert again. Again, so I will increase I. So now they are different. Now what should we do? If they are different, what can we do is that yeah, is that we should remove the elements from the queue from the top until we find the I where they are not different or they are same. So now as we reach I over here, what we'll do is we'll make a we'll make another local variable to store this position. Let us say st our is our currently pointing to this position. Now when they as they're different, we will pop it from the queue from the beginning. Now I will increase my I pointer. Now they are different. Now again I will pop. Now increase my pointer. Now they are different. Again I will pop. Now the I. As the stack, the queue is empty. Now there is no possibility of deleting or doing anything. So now what can we do is we will insert all these elements between this st value and our current I. So whatever values are present in this range, we will add all these elements into our queue. So now our queue will be 000. So after adding our is at this point. Okay, I forgot to tell you one more thing. So while we are popping the elements from the queue, we will increase our count point. Count variable. The count will be after three deletions, the count will be three. So after deleting, what will happen is that okay, after deleting, we are inserting zeros. So now the ith pointer is at one and they are different. So we should delete. We can delete zero and let me say, yeah, this should be also done. While when we reach a different element, here also we should make our st is we should store our value to this index. We should store the this value in the starting. It's the variable. So after deleting, now our I will be here, and this will be again deleted, and I will be here. They are different. This will be again deleted. While deleting, I should increase my count. So this will be 3 plus 3, which is 6 here. So after that our stack is empty. So what I told to do is we should add all the values from the ith value and st. We should add all the values in this range into a queue. We will be adding all the three ones. Now, as our I reaches the end of the string, we don't have to do anything. So our total value is 6. So this is the approach for this problem. I hope I made it more clear. So now let me walk through to the code. Yeah. So this is our string, and we are making count and I as 0 initially. After yeah, I used an array list here. You can also use a queue of a character, and I'm adding the first value of the string into my array list. And so I will check whether the top of the rear of the queue is same as the this. No. I should check the top of the, not where. Yeah. Uh, I told you differently. So you remember that, like we should check for the top of, the front of the queue is same as our current ith index or not. If they are same, we should insert into our the list. If they are not same, what we should do is we will make a start index as, and we will store the current position in the start variable. Now we will check uh, from I to where till we reach a point where they are not same, or sorry, they are same, or till we reach a particular position where our stack size is null or 0, then we will stop. So while they are not true, we will continue to remove the elements from the top of the array list. So, and while doing so, we are increasing our count pointer to 1. And after completing this while loop, what we will check is if the current size of the stack is 0 or not. If the size of the stack is 0 after deleting, that means that we don't have any value, and we have to like insert the remaining values into the I mean the from start to I, we should add all the values to stack. But if the stack size is greater than 0, yeah, we- I didn't tell you this thing in the previous method. Like, what if here after deleting three ones, because as we got three zeros, the sizes of the stack is 0. But if there is a case that where we cannot let me okay, if there is a case that if there are only two zeros here, so if there are only two zeros, that means that we can remove only two ones, and one is present. One is present. So in this case, uh, mostly what we should do is we should remove the one, because it will not make any kind of uh, it will not make any kind of difference to the next results. Like this is a useless value, or unused value. So we can remove the excess ones present before the 0. So we should remove all the elements in the array list if the size is greater than 0. So after removing, we will add the zeros into our array list. And again, this loop will be checked, like whether our top of the uh, array list is same as the ith index of the string. So again, this loop will be executed. Again, again the same process will be repeated. And finally, when we reach a value at the ending of the string, then we will return our count. So this is the best method to do this problem. And yeah, so I will upload the solution in my GitHub, and I will share the link in the description. So thank you guys for watching the video. I hope you enjoyed, and please don't forget to like and share.